Welcome back, B.F.D followers. I know I've been away for a while. I'm sorry, but lifetime happens and things have to be taken care of. But I'm back, and let's take a look at what I've been working on. When I last left you guys, I had been telling you that I broke my jig in the aft section, which holds the dummy axle and determines the drop ratio between the rear axle and the bottom bracket. And so I had to go back and remake it, and that's where we left off. Well, I've done that, and here's a picture of that, and it's more or less finished, and I'm going to show you kind of what I had to do to get it all done. What I ended up doing is grabbing some old leftover 80/20 extruded aluminum and some attachment hardware that I still had laying around from another project I had that allowed me to attach to my existing jig. And then I also had some leftover aluminum block that I think I showed in the last video that I modified to accept a new dummy axle mount. And here's what I did. Okay, so here's my assembly, and it's all mounted up so you can see what it's going to look like when it's done. And as you can see, it's pretty simple. The dummy axle is just held in by this 80/20 extrusion that is cut to match grooves in the dummy axle, and I just cut sufficiently through with a mill the slot so that it rests against that surface, so I don't have to worry about this being consistent on both sides since it's an extrusion. What I wanted to show you was what I did to ensure that this is indexed and can be repeated with a fair high confidence level whenever I take it apart or put it back together or have to move it. It's held in with only one bolt, and you can see that, or you would think that this would be swiveling all over the place, right? But what I did is I put an index pin on the back side, and that allows this thing to be adjusted. And I'm going to put another pin in there because basically this only locks it into one plane location, basically. Let me back that up. This surface gives me one index. This gives me two to a degree, but because the nut plate has slop in it, it's able to rock a little bit. So I have another pin that is hopefully parallel or in line with those two, that will lock this in perfectly perpendicular and parallel to the surface of this bar here. That way I don't have to worry about it being indexed correctly, and all this will do is pull down on it and hold it in place. And I like that so much that I'm thinking about doing the same thing over here and picking up two pin locations. It all depends on if these are in line or not, because I believe those are, we'll see how accurate they are. They need to be in high precision tolerance there, because if it's off, it can cause this to sit at a slight angle like this, right? Up, down. Can cause it to just be up, down a little bit. And then if this is not right, it can be up, down a little bit. So put those two together, you can have either compounding errors, tolerance errors, so it could really be kicking one end up high, or it could be, if I'm lucky, they would be canceling, so it'd be just level no matter what. But that's what we got to check. But I like that idea, so I don't have to keep worrying about making sure that I push everything to all the tolerances to one end when I do the tightening, or if you hit it and it jostles things out of alignment and you don't catch it, then your dummy axle sits on your bike like this, up or down, and could possibly go forward aft. But anyway, that's what we're going to work on today. And what I did for this is on my mill, I just laid out, you can see the scribe line there, and then I did the same thing with a scribe line down here, and then I laid these holes out as closely as possible to on that center line, because that is what is critical. The true test is this pin accurate with this pin location. So when I put this next pin in, will this be parallel to this line up here? And if it's not, then this bar will kick one way or the other, and that will be a bummer. I'll have to take that pin out and I'll just have to manually index it. But before I even get to putting in a new pin, I need to prep my aluminum block, cut it to length, and then I'll go and drill those holes. At the same time, I will be cutting the 80/20 aluminum extruded base plate that will attach to the jig too. I just wanted to get things squared up. Once the aluminum was all squared up and cut to length, I wanted to go and get the attachment points all mounted or drilled. Prior to doing the drilling, I wanted to lay out the attachment hardware so that I knew exactly where I needed to drill. And the next step was to actually then go and do the drilling. So I need to do that twice to make this tie down. One there and one there. So I just need to countersink it a little deeper. I'll do that one more time. All right. So I got those holes drilled, and just so you can see what I'm doing, I'm taking this 80/20 hardware, and it will allow me to attach this block on its side up against the other block, and that way I can move it up and down, or in this case forward and aft. And then I'll have the other plate that will move up and down that will give me the water line or the rise, as I've been talking about before. So this is pretty simple. You just drop your bolt through the opening here, and then you attach the nut plate on the back side, kind of like this here. My fingers are shaking today. And then you drop that into the hole, and you can see how this is going to allow it to slide and then clamp down, right, up and down. So I'll go do that right now. Just like that. And then you can slide it down to where you need it, right? And then you can lock it in place by, so now it's locked in place. And like I said, the orientation here, up and down, is not as important because it will stay parallel. It will just kick up and down from 0, which, as long as you're within your own self-prescribed tolerance range, that's cool. But if you wanted to, you could come in with an angle and tap it into place like that, and now you're totally perpendicular to this beam and parallel to the bottom bracket. Okay, so I fabricated my second pin and I installed it, and when you slide the dummy axle holder part in, it didn't sit flush, so my holes were just like, I think about 2/1000ths off. And so what I did is I ground the bottom side of this one right there. You can see that gives me just a little bit more slop, so I can bias every time by pushing up and holding it there and clamping. And you can see that is, as you go to 0, you see that everything disappears about the same time, that edge back there. So that tells me that this surface is parallel with this surface to within probably 1/1000th of an inch. That's probably a little too tight of a. It's probably more like 50/1000ths or less. But I'm going to check it out. I'm going to put it on a flat surface and run it up here. And hang on, I'll show you what that looks like. Okay, so here I have a big, it's a 3/4 inch cold rolled steel, hot rolled steel, and so it's not maybe what you would call a flat surface, but it's pretty damn flat and it's pretty consistent across. And so what I've done is I've mounted the dummy axle up into the jig, and I've clamped my outrigging bar down to that surface. And so what I should see is that the surface of this end of the axle should be the same as that end of the axle, and it should be, but we all know there are tolerances. So what I'm looking at is approximately 10/1000ths, within plus or minus 10/1000ths. Okay, so here we go. Actually, I'm going to remove these end bolts so I can get to the very end and be consistent. Okay, so I'm going to line up and come down, and I got 66/1000ths. Okay. And here I have 64. Okay, so there's 20/1000ths difference, and it's pretty tight here. So what I'm going to do is I'm going to pull this out, flip it around, and see what the difference is, because I think one end was slightly thicker than the other, but we'll see. So that was 65.5, 655. Interesting. And that was 64. So there is a slight difference. So what did I say? I was willing to accept about 10/1000ths. We're about 15/1000ths out of difference here, I believe. So I'm going to do a couple more. I'm going to change position here and see if there is a slight difference in this bar here, and make sure that I'm not going to work myself into a problem that I don't really have. Hang on. Okay, so I repositioned it, and I do have this plate has a little bit more variation in it than I thought it did. I went side to side, and I had actually about 50/1000ths variation there. and that wasn't good. So I checked it again on this edge, clamping it a little more tightly, even flush, and now I'm going back and checking the edges here, and so that's 64.2. And that is 63.1. So that's within what I had expected to be. And if you go in and I measured the diameter here, I have 75.4. And that is 1, 2. Oh, that's 75.2. Boy, that's pretty damn tight. That's closer than I thought. Oh, wait. That's 0.4. So, yeah, there is a slight difference in height. So, there's a slight difference in the diameter on this, not by much. It would be, that's in 10 thousandths, so it's about 5 thousandths difference in diameter. So 5 thousandths plus or minus the difference on the end there, that it almost accounts for it. It's about another 5 thousandths. That I'm willing to accept on the build. 5 thousandths up and down differential can be pushed out. When you push on your seat stays on when you weld, will deflect just enough to make up any difference there. Plus, when you actually do the welding, you're going to get distortion, and you're usually going to have to do some bending and preloading to equalize and level things out. So that I like. This is good. All right. Move on. Okay, now that we finally got the dummy axle assembly all mounted and finished, I can finally move on to doing the build. Okay, so the next video I'll have will be dealing with the dummy axle through axle mount to the ChainStay, and that would be almost the end of the video. All right, stay tuned. Thanks again for putting up with my delays.